Hello friends, this video on Redox reaction part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 3. Let's understand the competitive electron transfer reaction. There's always competition in life, and the competition is for us, for everyone actually. I believe for elements, human, the competition is to achieve stability. See, if a person is running in a Olympics, he is running to get name, fame, so that he can be stable in life. We are all studying, students study, people do job, they do business, just because they want stability in life. See, the elements also want stability in their life, and they can achieve this by gaining or losing electrons based on which side of the periodic table they lie. And I've explained these things pretty clearly in the class 11th atom chapter. If your concepts are not clear, please watch the chapter once again. So if you see a lot of students, they are racing just to win. They want to be winner, they want to be stable in life. Similarly, if you have zinc in a copper sulfate or copper nitrate solution, you put this zinc in a copper sulfate or copper nitrate solution. After some time, you see the color of the copper nitrate solution, which is dark blue, will turn very light blue, and zinc is we call it grain color. The copper from the copper nitrate solution will get deposited here, and you'll see a good deposit of copper here. You can do this in your lab. You can take a zinc, you can take copper nitrate solution or copper sulfate solution, just dip it. You'll see the dark color of the copper nitrate solution is minimized, and it almost becomes colorless, and you'll see a copper deposit in the zinc. The question is why it happened. So if you see the reaction that happened is here, zinc, when it reacted with copper sulfate solution, zinc got oxidized. Zinc became Zn+2, right? It lost electron, and copper got reduced. Copper nitrate reduced to copper, and that copper is deposited here. But if you flip this side, if you take a zinc nitrate solution and put a copper strip, you keep it for hours, months, years, there will not be any reaction. Why? Because if you see, zinc can oxidize more easily than copper. Zinc can oxidize more easily than copper if you're talking about the oxidation property, you can say. Zinc is a stronger oxidant than copper, and that is their property. That depends on the atomic structure, because zinc want to lose electron more than copper to become stable. And there is a competition between zinc and copper. Similarly, for other metals also we can create a competitive chart which can help us in predicting whether the reaction will happen or not. For example, in this case, zinc plus copper sulfate, the reaction happened, but copper plus zinc sulfate, the reaction didn't happen. Why? Because we know that the reactivity chart, if we develop a reactivity chart, we know that zinc is more reactive than copper, or zinc want to lose more electron more than copper. So we can develop a chart kind of this. For example, if you react zinc with copper, you get this kind of reaction. You react copper with silver nitrate kind of stuff, then you will see again you get copper plus. That means copper is more stronger than silver nitrate, or copper want to lose electron more badly than silver, right? Similarly, you can develop a metal activity chart like this. That means lithium wants to want to release or give electron more easily, or want to get oxidized more easily, right? So because it becomes Li plus and become more stable. Similarly, potassium, calcium, sodium, and this is the order. Gold, if you see, is in the last. That is very unreactive also, and that's why we make a lot of ornaments in gold. So this is a reactivity chart. If we say with this chart, we can find, if you say that I have a reaction between zinc and let's suppose this guy copper sulfate, I can see that reaction will happen because zinc will try to become zinc sulfate, right? or aluminum and zinc sulfate, I'll say yes, aluminum will become aluminum plus 3. But if I have iron and zinc sulfate, no, the reaction won't happen, because zinc sulfate, that means it is zinc is already in plus 2 and iron is in free iron, so zinc had more tendency to become zinc plus 2 than iron, so it will be in this stage. But if it is zinc and iron plus 2, let's suppose, so then zinc will become zinc plus 2 and iron will become iron. Correct. This is a metal activity series, and this is developed using tons and tons of experiments. So it's good to remember this activity series actually. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.